In the early surveys of the American West, government geologists described mountains in a way that feels almost contradictory. They were natural formations, but they often appeared structured. In reports archived by the United States Geological Survey, 19th century observers noted long, flat ridgelines, sharply defined faces, and slopes that seemed to follow consistent angles across entire regions. At a distance, some mountains looked less like chaotic upheavals and more like deliberate shapes, plateaus with clean edges, cliffs that ran for miles in straight lines, valleys carved with surprising symmetry. Of course, geology has explanations for all of this. Mountains are not random piles of rock. They are shaped by forces that operate over immense spans of time: tectonic uplift, erosion, sediment deposition, volcanic activity. Processes that follow physical rules. Patterns emerge from those rules. The simplest explanation is often correct. Still, the visual consistency can be striking. Travel through parts of Appalachian mountains, and you may notice long, parallel ridges running in the same direction for hundreds of miles. Move west to the Rocky Mountains, and the forms change: jagged peaks, steep inclines, dramatic elevation shifts. In the American Southwest, another pattern appears: flat-topped mesas, sheer canyon walls, layered rock exposed like stacked pages. Places like Grand Canyon reveal horizontal bands stretching across vast distances, each layer representing a different geological period. These formations are well studied. Sedimentary rock builds up in layers over millions of years. Erosion primarily from water and wind cuts through those layers, exposing them in cross-section. The result can look almost architectural: straight lines, clean edges, repetition. But there are moments when the resemblance feels stronger. Cliff faces that appear unusually flat, slopes that maintain consistent angles over large areas, mountain sides that look cut, not in a literal sense, but in a way that suggests uniformity. Early explorers occasionally used language that reflected this impression. Terms like walls, terraces, and steps appear frequently in their journals, not as technical descriptions but as attempts to describe what they were seeing. Natural formations, described in artificial terms. Modern geology explains these shapes through processes like differential erosion. Softer rock wears away faster than harder rock, leaving behind steep faces and flat surfaces. Fault lines create linear features. Tectonic forces push rock layers upward at angles that remain consistent across regions. All of this is measurable, observable, repeatable, and yet, when viewed at scale, the patterns can still feel unusual because they repeat across continents, across different types of terrain. Flat-topped formations appear in North America, South America, Africa, and Australia. Long, straight ridges appear in multiple mountain ranges around the world. The processes are the same, so the results are similar. That is the explanation. But similarity can sometimes feel like intentionality, even when it is not. Perhaps that is where the question begins, not as a challenge to geology, but as a reaction to perception. Why do certain mountains appear to follow the same visual patterns, even when they are separated by thousands of miles? Why do some ridgelines look as though they were shaped along consistent angles? Why do certain cliffs appear almost too clean? Maybe it is simply the nature of erosion. Water flows downward, gravity pulls consistently, rock fractures along predictable lines. Given enough time, order emerges from chaos. That is the foundation of geological science. Still, there are details that invite a closer look. In some regions, entire mountain faces appear flattened, as though sliced vertically. In others, terraces step downward in repeating levels. Certain formations maintain sharp edges that persist far longer than expected under continuous erosion. None of these features are unexplained, but together they create an impression, a visual language, one that feels structured, intentional, even when it is not. Perhaps I'm seeing patterns, or perhaps I'm seeing patterns are simply there waiting to be noticed. Because once you begin to look closely at mountains, not just as landscapes, but as shapes, you start to see repetition in places where randomness might be expected, and that leads to a quiet, persistent question. If these formations are entirely natural, why do so many of them look like they were shaped in the same way? The idea that mountains might look cut begins to sharpen when you compare different regions side by side. In the Appalachian Mountains, long ridgelines stretch in parallel bands running northeast to southwest with remarkable consistency. These ridges rise and fall in repeating patterns, like waves frozen in place. In the Rocky Mountains, the pattern shifts steeper, more vertical, with peaks that appear fractured rather than layered. Then in the deserts of the American Southwest, formations become even more geometric. Mesas, buttes, escarpments, flat tops with sheer sides. Places like the Monument Valley display towering rock structures that rise abruptly from the ground, their sides almost unnaturally vertical. Different environments, different histories, yet similar visual impressions emerge. Flat surfaces, sharp edges, defined angles. Geology explains these features through structure. Sedimentary rock forms in horizontal layers. When uplift occurs, those layers can remain intact, rising as a unit. Over time, erosion removes surrounding material, leaving behind isolated formations. The flat tops of mesas are simply the exposed tops of these layers. The vertical sides are where softer material has eroded away. It is a process of subtraction, not construction. Wind, water, time, remove enough material, and what remains begins to look deliberate. In regions like Grand Canyon, the effect is even more pronounced. The canyon walls reveal stacked layers of rock extending for miles, each layer maintaining a consistent thickness across vast distances. It looks precise, measured, almost engineered, but the explanation remains grounded in physics. Sediment settles in layers, pressure compresses it into rock, tectonic uplift raises it, erosion cuts through it. The same sequence repeated over millions of years. Consistency is the result. Still, certain features push that consistency further. Some cliffs extend in nearly straight lines for miles. Fault lines create fractures that run with surprising linearity. In some cases, entire mountain faces appear to follow a single plane. This is where the language begins to shift again. Linear, planar, uniform. Words that describe geometry as much as geology. Then there are terraces. In multiple regions around the world, mountainsides display stepped formations levels that descend in intervals, almost like giant staircases carved into the earth. Geologists attribute these to differential erosion and changes in rock hardness. Harder layers resist erosion, forming ledges, while softer layers wear away, creating steps. The explanation is sound, but the visual effect remains striking. Step, drop, a repeating pattern that feels structured. At this point, a different kind of interpretation sometimes appears, not within mainstream geology but at its edges. A small number of alternative theories suggest that certain large-scale landforms may reflect processes not fully understood, or that past environmental conditions far more extreme than those observed today could have shaped landscapes in ways that appear unusual from a modern perspective. Some point to ancient megafloods, others to glacial carving on a massive scale. A few propose more speculative ideas about large-scale erosion events that operated differently than current models predict. There is ongoing scientific discussion about some of these processes, particularly megafloods. Evidence of massive prehistoric flooding events, such as those that shaped parts of the Pacific Northwest, has been widely studied and accepted. Water, under the right conditions, can reshape landscapes rapidly. Cutting, scouring, flattening. Perhaps that contributes to the impression that something once moved across the land with enough force to carve surfaces cleanly, leaving behind edges that feel sharper than expected. Still, even these explanations remain within natural frameworks. No need for external intervention. No need for deliberate shaping, just forces operating at scales difficult to imagine. Maybe that is the key. Scale. Human intuition struggles with processes that occur over millions of years or across entire continents. When we see a flat cliff or a straight ridge, we interpret it through familiar experiences: cutting, shaping, construction. But geological processes, given enough time, can produce similar results. Not identical, but close enough to feel familiar. Perhaps I'm seeing patterns again. Still, the repetition is hard to ignore. Across different continents, different climates, different rock types, Mountains and cliffs often resolve into similar visual forms: flat, angled, layered, as if shaped by a common set of rules, which, in a sense, they are. The laws of physics do not change from one region to another. Gravity pulls the same way. Water flows the same way. Water flows the same way. Rock fractures under stress in predictable patterns. Given enough time, those rules produce structures that repeat, not perfectly, but consistently enough to be recognized, and once recognized, difficult to unsee. There is a difference between something looking designed and something being designed. Mountains exist in that space. They follow rules, strict, unchanging rules governed by physics, chemistry, and time. Those rules produce patterns, and patterns, when repeated, begin to resemble intention. Flat surfaces, straight lines, consistent angles. The human mind is trained to interpret those features as signs of deliberate action. Cut stone, built walls, engineered slopes. So when similar shapes appear in nature, the instinct is to question them, to wonder if something more direct was involved. But geology operates on a different scale of authorship. There is no single moment of creation, no single force shaping a mountain. Instead, there are layers of processes: sediment settling millions of years ago, pressure compressing it into rock, tectonic forces lifting it upward, erosion removing material gradually, then suddenly, then gradually again. Each step leaves a mark. Each mark contributes to the final form. What we see is the accumulation of those marks. An accumulation can mimic precision. A cliff face that appears flat may have been shaped by countless small collapses, each one removing irregularities until a plane emerges. A ridgeline that looks straight may follow a fault-line rock breaking along a path of least resistance. Terraces form where different layers erode at different rates, creating steps that appear intentional. Nothing random, nothing directed, just consistent processes acting over time. Maybe that is what creates the illusion: consistency. When the same rules apply everywhere, similar shapes appear everywhere, and similarity feels like design. But there is another layer to consider. Time removes evidence. Sharp edges in rock do not necessarily mean recent cutting. Some rock types resist erosion so effectively that their forms persist for millions of years. In dry climates, where weathering is slow, cliffs can remain remarkably intact. What looks fresh may simply be durable. What looks cut may simply be preserved. Maybe I'm connecting dots that were never meant to touch. Still, the question remains useful, not because it challenges the natural origin of mountains, but because it highlights how perception interacts with scale. We are used to seeing human-made structures. We recognize straight lines. We recognize symmetry. When those features appear in landscapes, they stand out. They invite interpretation. But nature does not avoid these forms. Given enough time, it produces them, again and again, across continents, across eras. The forests change, rivers shift, but the underlying rules remain. And those rules shape the land in ways that sometimes feel familiar, even when the processes behind them are far beyond human experience. So when a mountainside looks as though it has been cut cleanly, or when a ridge runs in a straight line for miles, it is not evidence of something unnatural. It is evidence of consistency, of forces acting the same way over and over until patterns emerge, patterns that resemble intention, but are not. And perhaps that is the quiet tension at the center of it. Not that mountains were shaped deliberately, but that the natural processes that form them can produce results so structured, so repeatable, that they briefly blur the line between what is built and what is formed, leaving behind landscapes that look, at a glance, like they were designed, even as the record insists they were not.